So we'll look at another one here, and square root of 24. We want to look for perfect squares. A perfect square, just to remind you, a perfect square is like 1, 4, 9, 16. Why are those perfect squares? Because if you take the square root, you get 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. And just in case you don't remember why, it's because 4 times 4, 4 times itself, is equal to 16. So now if I break this up, what I'm trying to do is I'm trying to break this into 2 square roots. So what 2 square roots can I break this into? Well, I could break it into 2 times 12, but neither one of those are a perfect square. I could break it into 4 times 6, which is okay because 4 is a perfect square. So what is the square root of 4? It's 2. What is the square root of 6? Well, it's not a perfect square, and there's nothing else I can factor out of it, so it's square root of 6. The other way that your teacher probably did it was to break it down in what's called a factor tree. So watch, if I break this down, break it into 2 numbers, 2 and 12. Break it down again, 2 and 6. Break this down to 2 and 3. I stop every time I get to a prime number. Alright, so now how do I tell what goes in and what comes out of the square root symbol? Well, anything that has a pair. Think of it like a dance. You have to go to the dance with a date. So these two can go together because they have a date. They can go to the dance. They come out as a 2. Well, how about the 2 and the 3? There's nothing for them. There's no date for them, so they have to stay inside the radical. 2 times 3 is 6. So that's the 2 ways to do these problems.